Again, we'll be covering exponent rules, negative exponents and the rules associated with those, addition and subtraction of polynomials, multiplication of polynomials, and polynomial division. The first problem is to simplify 9x to the 7th y to the 5th times 7x to the 6th y to the 8th. The important thing to remember here is that we treat coefficients differently than we treat exponents. The exponent rules tell us that we add exponents for the like bases, but the coefficients must be multiplied. In other words, we're going to multiply the coefficients 9 and 7, but for the variable x, we'll add the exponents 7 and 6, and for the variable y, we'll add the exponents 5 and 8. 9 times 7 is 63. 7 plus 6 is 13, so we have x to the 13th, and 5 plus 8 is 13, so we have y to the 13th. In this problem, we have a fraction raised to an exponent. And what we're going to do is we're going to bring that exponent in to each of the four bases. In the case where we have an exponent, we'll multiply 2 by each of those exponents, but when we raise the number 4 to the power of 2, we'll have 4 squared. Now to simplify this, we'll raise 4 to the second power, and we'll multiply all three of the exponent pairs. 4 squared is 16, and the exponents are x to the 18th in the numerator, y to the 12th, z to the 16th in the denominator. The rule at play here is the quotient rule. When we have the same base in the numerator and denominator, we take the exponent in the numerator and subtract from it the exponent in the denominator. So for the variable x, we'll subtract 13 minus 7, while for the variable y, we'll subtract the exponent 16 minus 5. 13 minus 7 is 6, and 16 minus 5 is 11. So we have x to the 6th, y to the 11th power. This problem shows the properties of negative exponents. In this problem, I have two bases that involve negative exponents, y to the negative 4th, z to the negative 7th. These two exponents are going to have to move to the denominator. These two bases will move to the denominator with a positive exponent. Watch out for the coefficient negative 5. Although we move negative exponents, we do not move negative numbers. The negative 5 will stay put in the numerator. So our result is negative 5x to the 6th staying in the numerator, and y to the 4th, z to the 7th in the denominator. The rule being displayed in this problem is the product rule. And the product rule tells us that when we multiply two like bases, we add the exponents. So in this case, we'll add 17 plus negative 32. Now we're adding a positive number to a negative number. In that case, we subtract the absolute values of the numbers and keep the sign of the larger number in terms of absolute value. 17 plus negative 32 is negative 15. Now when we simplify, we cannot leave an exponent that is negative. So we're going to rewrite this as 1 over x to the positive 15th power. The rule on display in problem 6 is the quotient rule. And the quotient rule tells us that when we have the same base in the numerator and the denominator, we subtract the exponents, numerator minus denominator. So in this case, that will be negative 6 minus negative 13. Remember that when we subtract a negative number, it's the same as adding a positive number, and negative 6 plus 13 is positive 7. So our result is y to the 7th power. In this problem, the rule involved is raising a product to an exponent. And we're going to bring that exponent into all three of the bases. We're going to raise 7 to the negative second power, then we'll raise x to the fifth to that power, and finally y to the negative third to that power. I want you to be careful. When I raise 7 to the negative second power, I cannot multiply that out yet. Keep in mind that 7 to the negative second power is the same as 1 over 7 to the positive second power. Now I can multiply out 7 squared to get 49 in the denominator. Let's take a look how this goes. Bring in the exponent, 7 to the negative second. I'll multiply negative 2 by 5 to get the exponent for x, and negative 2 by negative 3 to get the exponent for y. Now I take the two bases that have negative exponents, and I'm going to move those two to the denominator. So it's going to be 7 squared and x to the 10th in the denominator. I finish the problem by raising 7 to the second power. 7 times 7 is 49. In problem 8, it's a similar problem, except this time our exponent is 3. So we'll raise all three of the bases on the inside to the third power. Now in this example, the only base that's going to move to the denominator is y, because y has a negative exponent. Although negative 3 is a negative number, that does not indicate that we need to move that base to the denominator. We only move bases with negative exponents. We do not move negative numbers. So in the next step, we move y to the negative 12th to the denominator, changing its exponent to a positive exponent, and we'll finish off this problem by raising negative 3 to the third power. Negative 3 to the third power is negative 3 times negative 3 times negative 3, which is negative 27. As a good rule, anytime you have a base that's a number, be sure to raise that base to the indicated power. In this example, we'll be subtracting two polynomials. And the rule to remember when you're subtracting two polynomials is to distribute the negative sign to each term in the second polynomial. In other words, we're going to change the sign of 2x squared, negative 3x, and negative 11. Once we've changed those signs, the last step for us is to go ahead and combine like terms. 9x squared minus 2x squared is 7x squared. 5x plus 3x is 8x. And negative 17 plus 11 is negative 6. Keep in mind that when you combine like terms, the variable part stays the same, only the coefficients change. In this problem, when we're adding two polynomials, all we have to remember is that we need to combine like terms. We do not need to change the sign of the second polynomial of any of the terms. So we're going to go ahead and ignore the parentheses and combine like terms. We're going to combine 2x squared with 4x squared, which is 6x squared. We're going to combine negative 9x with positive x. That's a negative 8x. And then finally, negative 13 and negative 29 combine to be negative 42. On to multiplication. Many of us know this problem as FOIL, but really what you want to remember is that you need to distribute each term in the first set of parentheses to each term in the second set of parentheses. We're going to go ahead and multiply 5x by 3x and by 4. Then we'll multiply negative 8 by 3x and by 4. And we'll finish by combining like terms if there are any. 5x times 3x is 15x squared. Sorry about that. 5x times 4 is 20x. Negative 8 times 3x is negative 24x. And negative 8 times 4 is negative 32. Now I have two like terms that I need to combine. That's 20 x and negative 24x, which will combine to be a negative 4x. And again, this is a 15x squared, not a 5x squared. In this example, we have a binomial that's being squared. And you need to remember that anytime we square something, we're really going to multiply it by itself. So in this example, we'll begin by multiplying 7x minus 2 times 7x minus 2. We'll distribute 7x to both terms inside the second parentheses, and then negative 2 to both terms. That's going to give us 49x squared minus 14x. Now we distribute the negative 2 and get negative 14x plus 4. And we finish by combining like terms. Negative 14x and negative 14x make negative 28x.